little bio, we are going to hopefully finish up section 2 with this video. And again, remember this section is science in context, which again is some of just the ins and outs of science. Again, we've talked about good characteristics to possess and how science can help us with practical problems and how technology plays a role. So now what we're going to talk about, again, is once we actually make a new advancement and things like that, we have to actually share our ideas and make sure that our ideas are reviewed by someone else, because again, maybe we made a mistake that we didn't notice before. So what we have next is something called peer review, and we're going to talk about why peer review is published. So publishing peer-reviewed articles in scientific journals allows researchers to share ideas and to test and evaluate each other's work. So again, this is a key, this is huge in the scientific field. If we just had one person studying one thing all the time in different places around the world, then if that one person makes a mistake, then we're just going to widely accept it, and we're not going to be in very good shape, especially if it's a matter of public health and safety and things like that. So we have to be able to share and evaluate each other's work through a process that is called peer review. So peer review is very, very important. Peer review. So scientists, again, share their findings with the scientific community by publishing their articles that have undergone peer review. So in this process, scientific papers are reviewed by anonymous, independent experts. So that's a big thing. You're not going to have your best friend peer review your paper because they're just going to be like, oh yeah, that's great, 100%, we're going to publish it, you're going to be famous. So no, in order for you to get your ideas out there for the scientific community, someone else has to look over it and ensure that you did not make any mistakes. So some specific things that the reviewers are look for, they look for oversights, which means something that the original researcher might have overlooked, unfair influences, fraud or mistakes in techniques or reasoning. They provide expert assessment of the work to ensure that the highest standards of quality are met. So basically they're just making sure that someone isn't trying to get their own ideas out there. They didn't tamper with anything. They did the process the correct way, and therefore the results that they have were obtained using the correct method. So that is huge for peer review, because again, we don't want to have people just publishing things out there in highly regarded scientific journals that aren't true. That's what the internet's for. People put anything they want to up on the internet. It doesn't necessarily ever have to be true, but this is one of the instances where it is. And again, some of the benefits of sharing our knowledge and new ideas. So again, once the research is published, which after it's gone through the process of review, it may spark new questions. So each logical and important question leads to a new hypothesis and must be independently confirmed by controlled experiments. So again, even once it's published, it's been accepted, yes, this is correct, people around the world are going to continue to study it, continue to try to make changes to it, continue to try to improve upon it, or maybe try to throw it out altogether. So that is, again, there's nothing wrong with that. That is one of the biggest driving forces behind science. So again, our examples are going back to the salt marsh. So the findings that the growth of salt marsh grasses is limited by available nitrogen suggest that nitrogen might be a limiting nutrient for mangroves and other plants in similar habitats. So if you don't know, a mangrove is a type of tree that it grows in more of an aquatic environment than what a usual tree would. So because scientist A published the growth on salt marsh grasses, scientist B on the other side of the world has mangrove trees that grow in a similar climate, so maybe he's going to run an experiment to see if nitrogen affects mangroves in the same way that it affects the salt marsh grasses. So again, it can constantly build upon one another over and over again. It can be repeated, and when it is repeated enough to where we find something that has been more widely accepted, we kind of dive into the realm of something that's called a scientific theory. And in science, the word theory applies to a well-tested explanation that unifies a broad range of observations and hypotheses, and that enables scientists to make accurate predictions about new situations. Now that word is a mouthful, and in class, I'll try to break this down for you a little bit, but for right now, maybe get down theory and get it well-tested explanation that brings together a bunch of observations. And I'll get to the rest of that in class because that is a mouthful and I don't want you guys to freak out about that. But make sure that you have something jotted down about what a theory is. Maybe try to put that into your own words, and I'll try to put it in my own words to help you understand here in a little bit. And now, Getting again more in depth with the theory. So evidence from many scientific studies may support several related hypotheses in a way that inspires researchers to propose a scientific theory that ties those hypotheses together. So again, that is if we have multiple things that are coming together, again, they are giving us the same results over and over again. So maybe we can say with certainty that this is going to be correct and happen most of the time, so we can in fact call this a theory. So again, I kind of already summarized all of that that's written there, so I would mainly jot down that maybe it ties hypotheses. Oh, man, I really cannot talk. Ties hypotheses together, and again, well tested. Again, it's not just one person doing it over and over again, and again, like I said, thoroughly tested and supported by many lines of evidence that become the dominant view. But then it is tested over and over again. But this is another big part right here. Write down, no theory is considered absolute truth. That is a big one because science is always changing as new evidence is uncovered, and a theory may easily be revised or replaced by a more useful explanation. So make sure that that is one of the more important things you write down from there, that again, we might test these things over and over again, but we cannot consider a theory to be the absolute truth because new things will pop up, we'll learn new information, and that will change our way of thinking. So after we have all of these theories come up and we study the science, how are we going to relate science to society? Because that is kind of the ultimate goal. We come up with these theories for a reason, to help us out as a world. And again, it helps us also involve understanding its context and its limitations. So maybe how we can't necessarily apply every single aspect of society, or every single aspect of science, to every single aspect of society. So many questions that affect our lives require scientific information to answer, and many have inspired important research. But none of these questions can be answered by science alone. So we need society and other aspects to come in and kind of help us out when it comes to science. So scientists' questions that involve the society in which we live, our economy, and our laws, and our morals, and our principles. So researchers test shellfish for toxins that can poison humans. So should shellfish be routinely screened for toxins? Now that is not just a question of science, because someone is going to have to put up the money, like with our economy, to make sure that that is actually going to be able to happen. Maybe there's laws, maybe the fishing industry doesn't like that law or something like that. Who knows? There's a lot more than what meets the eye when we talk about, again, maybe a problem like this. Because it's not just science. We don't just have a scientist that can go out there and screen those shellfish for toxins at any time. They're going to have some type of funding, some type of support from outside sources. So that is, again, science and society need to kind of work with one another to make sure that all the advances that are being made in order to help out our community. And then now, a big thing that comes up with science, again, to wrap this up, is something with ethics and morality. So when scientists explain why something happened, their explanation involves only natural phenomena. And again, science does not include ethical or moral viewpoints. So again, people can't take their personal views and try to stick them into science. Again, it's not ethical, it's not right to do. So for example, biologists try to explain in scientific terms what life is and how it operates. So we explain why our cells do what they do, how they're able to carry that out. However, we can't explain why life exists or what the meaning of life is. We have no idea how to reach those answers. Again, we can tell you why your body operates the way it does, how it makes energy, but we can't give you a philosophical answer about why we are all here. And okay, so again, our last one here is we're going to talk about bias. So bias is a way where, again, talking about ethics here, is when your particular preference or point of view is personal rather than scientific. So anytime we're involved in science, we need to make sure that bias is left out. It has really no room for being in the scientific community. And again, that kind of wraps it up with our ethics. So that is it for section 2. Let me know if you have any other questions.